EV vehicles. So how do you charge them? From the grid, peak, off-peak, solar, storage? What really is the best strategy? Ellie from Greenwood Solutions here. This week we're looking at EV charging. So after watching this presentation, you'll understand what are some of the charging options available and what's the best way to attack this from a total energy management perspective. Electric vehicles are getting more and more popular as an alternative to internal combustion engines. Instead of stopping at the petrol or gas station, the EV owner has a range of options in which to choose, and effectively there are three modes of charging. Mode 1, effectively you charge at home with a portable unit and you plug it into a dedicated AC socket. Mode 2, it uses an AC EVSE which is hardwired into the house, a dedicated circuit, so that's an electric vehicle supply equipment. Mode 3, DC charging. The EVSE is a high-powered AC to DC charger not found in homes. Most of the portable chargers available are single phase with varying outputs, and there are some that can use three-phase AC. The single phase units have capacities up to 15 amp and use a plug with a larger than normal earth pin, but there are heavier duty options around. Some have a screw fitting, and the more industrial ones will have a socket that matches. The 15 amp units are versatile in that they fit into standard power points, but you'll need a 15 amp to 10 amp converter. The issue is that the charge times on these units is long with a max of 3.5 kilowatt output. Same as portable units, except they are housed in a purpose-built enclosure mounted on a wall and are wired directly to the house switchboard. They come in single and three phase from 7.2 kilowatt up to 22 kilowatt. Cables can be built in or portable, with pros and cons with both approaches. For more information, I thoroughly recommend an article in Renew issue 156 by Lance Turner, the guru. It goes into great detail concerning the different methods of charging, the pros and cons, potential network interference in the future, and a great buyer's guide. And there's a link below. All energy usage should be looked at from the perspective of a T.E.M.S approach, total energy management strategy. And in the examples presented, we make certain assumptions concerning the EV battery's capacity, the owner's drive profile, domestic charging access and solar contribution, and more. We'll be looking at a range of options from full peak grid charging to a solar off-peak charging strategy. So before getting stuck into it, we have to make certain assumptions, which are: the customer has an EV battery capacity of 100 kilowatt hours and drives about 400 to 500 kilometres per week. Rapid charge is not an option for this customer, so we'll be relying on home charging. Customer has a 5 kilowatt solar system at their home, has a peak and off-peak tariff arrangement. Peak Monday, Friday 7 a.m. to 8 p.m. Off-peak Friday 10:01 p.m. till Monday 6:59 a.m. Peak costs 30 cents a kilowatt hour and off-peak 14 cents a kilowatt hour. Charging option 1, just from peak grid power. In this situation, the customer tops up over a few nights after solar production hours and turns off charging before the off-peak tariff kicks in. The total charge needed to replenish the battery is 80 kilowatt hours divided by 0.85, so 94 kilowatt hours, because we never fully discharge all the battery's capacity. The max current he can extract is 15 amps, so 15 amps times 230 volts is 3.45 kilowatts. Takes 94 divided by 3.5 equals approximately 27 to 28 hours to achieve a full charge. So the total cost per week is $28.20. Per year, this is $1,466. After 10 years, assuming a 2% increase in electricity per year, it will cost $16,056. And the total kilometres covered will be 260,000. Charging option 2, just from off-peak grid power. In this situation, the customer tops up during off-peak periods, either after 10 p.m. and before 7 a.m. Monday to Friday, on the weekend, or a combination of both. Total charge needed to replenish the battery is 80 kilowatt hours divided by 0.85, the same, 94 kilowatt hours. Max current he can extract is 15 amps, so 15 amps times 230, 3.5 kilowatts. And again, it takes approximately 27 to 28 hours to achieve full charge. And the total cost per week is $13.16. Per year, this is $684. And after 10 years, assuming a 2% increase in electricity per year, will cost $7,493. Charging option 3, from peak and off-peak. In this situation, the customer tops up just during peak and off-peak with a 50-50 split. The total cost per week is $10.34. Per year, $538. And after 10 years, assuming a 2% increase in electricity per year, will cost $11,774.89. Charging option 4, solar and off-peak on weekends. Now, the only time the customer can utilise his domestic solar system is on the weekends, but there are a few assumptions that will have to be made to make this example realistic. The ability of the 5 kilowatt system to service the 3.5 kilowatt load is restricted to only 3 hours a day. So the total contribution from solar is 6 hours a week, just on the weekends. The other 19 hours is from off-peak grid electricity. So, per week, this equates to $9.24. Per year, $480. And after 10 years, assuming a 2% increase in electricity, it's going to cost $5,261. Charging option 5. Now this time we're going solar all the way. So the ideal scenario is for the EV's battery to be charged completely from a renewable energy source, but unless the owner has access to on-site charging, which indeed may be the case, the direct contribution from solar will be limited to the weekends, and this assumes that they won't be driving the car at all. There is another option, and that is a correctly sized solar system in conjunction with an energy storage solution. Let's assume that the customer has a larger solar system and a Tesla Powerwall and intends to charge from it. Charging option 6, solar and batteries. In this order, the customer's EV will be charged directly from 3 sources and in no particular order: solar, off-peak electricity, battery storage during evening peaks. So we will have to make some assumptions in regards to the contribution of each. Charging option 6, solar and batteries continue. We know that we can directly charge on the weekend and contribute 6 hours a week to the EV battery load. This leaves 19 hours of contribution from the other 2 sources. Solar on the weekends is 6 hours. Off-peak electricity is 3 hours. Battery storage during the evening peaks, 2 hours a day, Monday to Friday, total of 10 hours. Total cost per week is $1.45. Per year, this is $76, and after 10 years, assuming a 2% increase in electricity, will cost $825. So this table effectively shows the different charge strategies, the cost per week, the cost per year, cost per 10 years, and the pros and the cons. Conclusion. As more and more consumers start purchasing EVs, strategies will need to be developed in regards to usage and also charging regimes. Relying on purely peak grid power will not only cost the owner, but put undue stress on a power system that is already fatigued. Using a combination of solar, cheap grid power and storage results in the cheapest yearly costs, but we haven't factored in the purchase price of these renewable energy systems. A prudent approach involves a cost-benefit analysis of all approaches tempered by financial realities, drive profiles and access to off-peak grid and renewable energy sources and storage options. Be warned, EVs are here and they are not going away. Thanks so much for watching our presentation on EV charging and the different charging strategies available. I'm Veli from Greenwood Solutions. If you have any questions, any inquiries, even any answers, feel free to drop us a line. And if you like what you see, hit hit that subscription button and tell your friends. See you next time.